All right. So our next presenter is Ivo from HackSoft. They're one of our sponsors. He's going to be talking about some Django magic with query set. Some stuff that we have never heard of, right? Come on. Yes. Hopefully. All right. Off you go. Hands down for Ivo. Let's do this.
Hey guys, my name is Ivo, and I'm going to talk a little bit about Django ORM and queries optimizations. I'm going to move this arrow from here. Yes? I'm 23 years old, and I write code for 3-4 years. And I mainly use Python and JavaScript for developing web applications. How many of you have used Django or work with Django? Great. So I'm happy to work with Django with these great people from HackSoft for 3 years. And we use it to build the stable applications for our clients to be able to solve their needs, their problems. So the first thing when I hear Django ORM is the question, why should I use an ORM or why should I use the pure SQL? So they both do the same job. If you implement the right abstraction, you can do almost everything with both of them. So the pure SQL, the pros are that it gives you the freedom to do everything that your database are the support. And the ORM gives you the whole power of the object-oriented programming. So some query with pure SQL will look like this. PsychoPG is the adapter for the Postgres that Python uses. So you write your SQL as a string and put it to cursor.execute. It does the whole job. But as soon as the project became larger enough, it's possible to become impossible to maintain this, to support this. Because you will have large SQL files that almost every insert query is the same, or almost every select query is the same. And you will start putting your repeatable parts in some abstraction, and it's possible to kind of implement an ORM yourself. And you already have it. Another bad thing here is that using pure SQL means that you couple your business logic with your database backend. So once you replace your backend, you will need to rewrite each SQL query that you've written in the project. And here is the code with the ORM. This is just the Python class that defines two fields. And this is the Python representation of a SQL table. So Python is the dynamically typed language. That means you do not need to specify the type of each variable that you use. But we do this here. And we do this because every database must know what type of value it will store in each column in the database. It's just the hardware limitation, if you can say it. So a basic insert query, we can make it with mytable.objects.create. Simple as that. And the good thing is that if you have the proper setup, if you use tuned ID or editor, you are able to refactor your business logic and fit your database to it at the same time. You will not care about how your database will migrate the data, and so on and so on. So here's in the web application database context, this is the architecture that each application if it uses the ORM, you have the Django, which keeps your business logic. All the validations, authentications, all code that actually do something. You have the database, which only job is to store your data and to be able to give it to you as fast as possible. So Django understands Python. Database understands SQL. And the ORM is the black box that is responsible to translate the SQL to Python and Python to SQL. And here's how we do it. The ORM interacts with Django with these classes, these models. And once you define a model, you create database table. And once you have this table, you have the objects class property, which represents the query set or manager. And you're able to communicate with the database with CRUD operations. You do this by calling some methods, .o, .values, .valuesList. And the ORM does some magic in it and sets some SQL queries. And it receives some database rows if you select something, or some query result as deleted an object. So here's the black box. If you need this translation, you will need top layer APIs to the Django and the database. So ORM communicates with Django through query set and managers, model.objects. And it communicates with the database with this backend setting that we set in the Django settings. This is actually the adapter. If you use SQLite, it's embedded in Python. If you use Postgres, you will use PsychoPG. And this is the only part of the whole application that knows what exact SQL query will be produced by your Python expression, as it is specific to a specific database management system. So we need some second layer, which is the SQL compiler. Since every query is a Python structure before it becomes a SQL string. And this SQL compiler transforms your structure to adapter call, which will produce the query. So here's the basic user model. We have name and age. We have query set and managers that allows us to make any operations with the user. If we write user.objects.o, it produces the basic query, select everything from users. If you write user.objects.filter something, it will produce the basic select query with where filter, where SQL calls. So it sounds easy, but writing these simple expressions allows us to not think about what exactly are we doing under the hood. I mean, you write Python expressions, but sometimes you're not sure where exactly the query is executed. And you know that since you must take the control over your code. You must know where exactly any SQL query is executed. So we have 11 statements. And it's not explicitly, I'm not explicitly sure where the query is happening here. Maybe on the first one, where I call .o, but on the second one, I call .o over .o, which is actually the same query, but I'm not sure. So the ORM, we said the ORM has three components: model, manager, and query set, where manager and query sets are replaceable each other. And the actual implementation is that your basic query set has this method and other, but you have some CRUD methods that you read something with get, first, last, order by. You make some update, write operations with create update. You make some. You have some join utils that's prefetch select related. We'll talk about this later. And these methods values list.o that are doing something with your objects in the database and give you different Python structures. So the interesting part here is every query set has a query. So if you write user.objects.o, it will produce empty query without filters. So it will be select everything from users. And at the moment you do user.objects.o.filter, it will clone your whole query set and it will make a clone of your query and it will create a where node attached to your query that will represent the where class. So it's basically a mathematical tree. It's a graph. And every time you modify a query set, sometimes it creates a whole copy of the query set. And this is very powerful since it allows you to reuse your ORM expressions. And once you've written, for example, filtering logic, you can reuse it for update, delete, or create, or update. And it has something that's called iterable class, which is really interesting, I think, because the iterable class, basically what the ORM does when you call user.objects, for example, .values list, it clones your query set with query, with where node, with everything, and set iterable class that defines what the database row will look like when you start using them. For example, values list returns a list of plain values. So if you call flat true, it will return just the ID, this expression right here. And the iterable class looks like this. And this is good because it's a little bit messy, but if you look at the for loop, that's the place where your query is executed. So once you instantiate your query set, you don't execute the query. But once you call the iter method, you execute it. Once you call anything that calls the iter method, for example, list comprehension, for loop, or everything, that's the place where the query, the select query is executed. And it's a generator. And since it's a generator, it means that except we have the control over the query execution, we have the control over the moment when the database row are loaded into memory, the use statement. So if we define our own custom iterable with our own custom method, we say, use my data structure, which is some dict with specific value name, with some counter, but use it only if counter is divided by 2 and returns those. And this means that it will execute the query at the same moment, but it will load into memory half of the objects, half of the query set. So the basic principle are that the query set are always immutable. Once you do something with a query set, it's a whole new query set. The iter method of a query set means that you make a SQL query. And the iterable class is the place where you say what your database will look like. If it will be ORM object or dict or list or something. And if we get back to this code, the first one, we instantiate the query set. It doesn't make a query. The second one, we just clone the query set. There's no query. The third one, list comprehension, calls the iter method, so we have a query. The fourth one it's a generator, but the generator is instantiated by the query set, which is a generator. So the return method will be called, so it's a query again. We make a query. The filter method on the fifth line, it does not make a query because just calling the query set with a where node. The sixth line makes a query because it's iterable. The seventh line does not make a query because we have made the query at the third line. We already loaded the objects in the memory. The eighth line will not make the query since it's already made, but it will load the objects into memory since the length requires an iterable to calculate the length. The ninth line will actually make a query. The 10th line will not make query because it's already iterated over it. Or this one. So it's good. That's good because once we know how the ORM construct the query and the moment of the execution, we have the control to say how our code will behave. And looking at that, here are some tips about it. If you have a large database table, and by large I mean more columns or more objects per table. If you have more columns or columns with a lot of data, it's a good idea to use only and defer. The only method says that user.objects.only from full name will select only the full name from the table. And once you call user.h, for example, to make a new query. But if you only need the full name, that's the place where you can do it. The defer is the reverse only. So it says, select me everything from the table without the field I don't need. And if you have many objects in the table, no matter how column you have, it's a good idea to use lighter data structure. So if you don't need objects, you cannot use them. If you just want to return something from an API or the plain view, you can use just dict. If you have some slow Python logic, if you filter a huge amount of objects in your Python code, sometimes it's the end result will be faster if you make an extra query that filters the thing in the SQL in the database instead of doing this in the Python. It all depends on the context, but sometimes it is. And the last one is not a good idea to use order. It's a good idea to use order by as many times as you can. And this is because some model.objects.o is not ordered by anything. It's 99.99% sure that it will order it by ID, but you cannot be sure by that. And if you look in the Django documentation, it says that it uses the default ordering of your database. So for Postgres, for example, the default ordering is the order that the Postgres insert the objects in the database in the physical hard drive. So it should be by ID, but it's not sure. And sometimes you have random failing tests that you have to fix and debug that. Yeah. So that's all about the ORM. Queries optimization. Django makes it easy to optimize queries for insert or update, since it just provides bulk create or filter something and update it. And you hardly have a problem with it. The same thing is with delete method. So the select clause is a little bit tricky. And we faced these three types of problems, which caused really slow APIs, and we needed to make them fast somehow. So the first, too much queries. You have an API or view that makes 6,000 queries because it uses 10 tables from a database, and you have relations between them. So the first thing, Django provides select related and prefetch related. If you have two models, user and share account, one shared account has multiple users, so the user has foreign key to the share account. Then if you call user.object.o, it will just select the users. But if you say user.object.select related my shared account, it will join the users table with the shared account table. If you want to get all your share accounts with their users, the reverse relation from these models, you can use prefetch related. The simple, the prefetch related actually does not save your query. It will make the query, if you don't need users but you use prefetch related, it will make second query for this table. That's the tricky part. So once you call iter for this query set, it will produce both of the queries. So the first tip is to use select related and prefetch related for these simple types of relations. But if you have too much data, if you have this model structure, which means you have users. Every user has multiple playlists, and every playlist has multiple songs. So this structure. But then we define some property in our playlist, and we must get the total length of the old songs in the playlist. And the length is defined in a song model. So it's easy to make it with a for loop. Just select prefetch related the playlist, the songs, and calculate it. But if you get, let's see this example. This is the same code, but instead of for loop, it uses list comprehension. And it's one line just to make it less code. So if you want to get all the users, total length of their playlist, and if we get 10 users and 10 playlists per user and 10 songs per playlist, we need to fetch 1,110 database rows from 3 different tables just to calculate one single integer value, which works, but it's not a good idea. So if we do this with the pure SQL, it will be just a group by clause, aggregation sum over the group of the playlist. And looking at the models again, we have the songs total length for the playlist and the playlist total length in the user. The SQL query will look something like this. There is a subquery inside the main query that group by the playlist by the user, the playlist. Sorry. And let's see the playlist model. We need to get the sum of all songs. So we can redefine the query set for this playlist and make some method that's called collect, for example, which will make the trick. So this method we call the query set embedded annotate method. The annotate method means that you want to select a field, but you want to rename it. So, for example, if the playlist has length, you want to rename it to ASDF or something like that. In this example, we want to make the aggregation in the query set and then annotate it to the underscore songs total length. And the one thing we need to do is to write the code in the songs total length class method of the query set. The Django ORM provides a subquery class which accepts two arguments, query, which is the subquery expression inside, and the output field to know what type of value the end result will look like. So the output field here will be integer field. And the query set will be a song query set that will code the values with the field that we want to group by. And the things left to do is to make the aggregation, the specific aggregation over it, and says which group we need to get. So the aggregation is sum of length. And this query set, without the third line right here, will just group, we'll make this group, but we'll not know what group is for what. It won't know how to differentiate the groups for a specific song. So we need this filter, playlist ID, which is the outer ref. The outer ref means get me this field from the outer query, the basic query. And this is the way to do it. So we have modified our property, the song's total length, with if has etc. For the field that we annotated, and just return it. So once we call playlist.objects.collect, it will produce the query that we want. Okay, now we need to define the same thing for each user. We need to define user query set that will have a subquery from all the playlists grouped by user ID and filtered by the ID of the user, and the aggregation of the playlist annotation, which is the annotation that we've written in another query set, the song's total length. And here's the end query, how it looks like. So the tip 2 is use subquery and outer ref for group by clauses for any type of aggregations. And the another problem that we faced is having too much data and too much queries. And here's the basic user model that has just two fields, first name and second name, and has some property that interpolates these two fields into some verbose name. So if you have 10,000 users, we need to fetch them as ORM objects to use this property. Because if you have dicts, we won't be able to use it. So what we can do is same thing. We already found the user query set, and we use this annotation by the expression wrapper that comes from Django, and say the f function is a util that refers to a database row column. So we say we need the new annotation, which will be char field at the end, but it will be a result of the first name and second name with name appended. And this is the way. One really helpful package that we use daily is this Django debug toolbar. It allows you to see every query that you make per request and the exact moment in the code, if you extend some of the rows, where exactly you made the query. It's really helpful, and it helps a lot. But doing all of this causes some artificial problem. That is, how are we sure that this actually works? I mean, we see the end query, but we're not sure it works. So if we have, let's assume we have the test for the models for these properties, and the test look like this. You have some song, and you assert the length that is calculated with the Python property. So the only thing you can do, you need to do, is to make two lines that are get the song by ID, but with .collect method, which will annotate the expression, and assert the same thing. So you will be sure that your annotation logic is exactly the same as the Python code you've written. And this is one of the good reasons to keep your Python logic in your properties, not to delete them. Because you need to have an explicit place where you've written your logic and you know how exactly it works. And another reason is that if you select a model that has a foreign key to a model you've predefined the collect and annotate something, let's say you select related. You have user that has foreign key to a profile. And you have user.object.select related profile, but the profile has some property that you've annotated. So the user.profile.something does not know about the annotation, since you didn't get it from the .collect query set. You got it from the .o basic query set. So the Python code, the Python code here should stay, but once you need to calculate it into the database for performance, you must define it in your query set. And I hope it was helpful. Thank you.
You still have 12 minutes. All right, so let's answer some questions. You have like 3 questions on the queue. So, any thoughts of using SQL Alchemy over Django?
I have used SQL Alchemy for side demo projects. I didn't use it I haven't used it with Django actually. So I can't say if it will better fit with it. How does ORM prepare with native SQL performance-wise? Well, actually, you fire a SQL query anyway. The slow part of the ORM is constructing this mathematical tree, which is represented by query set query and where nodes. And in the end, it's just a SQL query. So the ORM is slow to produce the query, but it's as fast as the pure SQL query string as a performance of executing. The next question, won't be easier performance-wise to make use of SQL views and delegate the work to database while keeping metadata of your data application? Well, yes, it will, but the good thing about the ORM is not that it allows you not to think about the SQL. You must know what SQL query you want to make, but it allows you to maintain that SQL query easier. Because you will write a SQL query that's 100 of lines, but once you have to change it, it's much easier to write Python code and write tests in Python than edit a SQL in some file. I think so. Should I and can I add to my test suite some assertion that will check the count of my queries? Yes, test case. I'm not sure if Django.test case have it, but REST frameworks unit tests have it for sure. It calls a certain num queries property, I think. Yeah, let's call that. And you have a certain good views for Django views. Is it better to use raw SQL queries to remove complexity of the ORM? Maybe the user playlist songs example can be good to place to use raw SQL. Yes, it will be easier to write, but I think it will be harder to maintain. Because let's say you have to rename some field. You have to rename some field from any table, or you have to rename your table. You have to grab all of your SQL and see if it's up to date with your database now. You have already defined your database with Python classes. So I think it's easier to use this abstraction to make expression and maintain it after all. How big is the overhead to parsing raw from database and constructing over instances? Well, we've tested that before. We had an API that loaded about 4 or 5 seconds, and it made around 50 queries. And we used objects for this. We have many objects, so we used pagination alongside the other things, but once we changed the ORM objects with dicts, from 5 seconds, the performance, the speed of the API was around 2 seconds, something like that. So it's the ORM object is really heavy. If you don't need it actually, you may not use it. And you need it if you need some property of it, or you need to update something for it, to it.
Okay.
Oh, yeah.
That's it. Also a heads up from the audience, if there's a follow-up, if someone of you has posted this message and you want to have a follow-up, raise your hand. I'm noticing everybody in the audience, so I'm just going to bring the mic to you. That's about it. Thank you very much for your talk.
This is my first time attending PyCon Balkan. It's a great experience. It's a great organization, great place to go, and thanks for coming.